Below, in this lecture, we'll find out the radius of the circle. In the drawing, we have this circle. Inside the circle, we have chord AC that is equal to square root of 2 units in its length. Chord DB equals to 2 units. And this angle DEB equals to 45 degrees. And our mission is to find out the radius of this circle. Okay, so actually we will use two rules in order to find out the radius of the circle. The first rule is that the central angle is twice as big as the peripheral angle resting on the same chord. Again, the central angle is twice as big as the peripheral angle resting on the same chord. Here we have the peripheral angle ACB that's equal to alpha, and this peripheral angle rests on chord AB. And we have also the central angle AOB that rests on the same chord AB, and therefore the size of angle AOB, the central angle, will be twice as the size of the peripheral angle AOB that is equal to alpha. Therefore, the central angle, the peripheral angle ACB equals to alpha. Therefore, the central angle AOB will be equal to 2 alpha. Okay. So the central angle is twice as big as the peripheral angle that rests on the same chord. Okay. And we have also the law of cosines. The law of cosines is true in any triangle. This triangle ABC, could be any triangle. The length of side AB is A, side AC equals to V units in its length. Side BC equals to C units. This angle PAC equals to theta. And according to the law of cosines, in this triangle, C square equals to A square plus B square minus 2 times A times B times cosine theta. Okay? So from this equation, it is very easy to arrive to this equation that cosine theta equals to A square plus B square minus C square over 2 times A times B. Okay? Again, cosine theta equals to A square plus B square minus C square over 2 times A times B. Okay. So first of all, we define the center of this circle, this point as O. In the next step, we join points O and B together by a straight line, points O and D, points O and N, points O and A, and points O and C by a straight line. So all those 4 line segments OB, OD, OA and OC are the radii of this circle. Why? Because they start from point O and ends at points that are on the circle itself, and this is exactly the definition of a radius. We define the radius of this circle as capital R, therefore OB equals to capital R, OD equals to capital R, OA equals to capital R, and finally OC is also equals to capital R. Okay, so here we'll focus on the straight line AB at point E. This point equals to 45 degrees, therefore the missing angle here must be equal to 135 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the upper side of AB at point E, we have this angle that is equal to 45 degrees, plus the missing angle. In total they must be equal to 180 degrees, according to rule number 1. Therefore the missing angle must be equal to 135 degrees in its size. In the next step, we'll focus on chord AC. The peripheral angle ADC, this peripheral angle rests on chord AC. We define the peripheral angle ACD as y over 2. Therefore, the central angle AOC that rests on the same chord AC must be equal to 2 times y over 2, that is y. In the next step, we'll focus on chord VB, this chord. Here we have this angle, peripheral angle BCD rests on chord DB. So we define this angle as x over 2. And therefore the central angle DOB that rests on the same chord DB will be equal to x over 2 times 2, that is x. Okay. Actually, peripheral angle ABD, we define it as x over 2, and here peripheral angle ABD rests on chord BD, and it is equal to x over 2. Therefore the central angle DOB must be equal to x. Okay. In the next step, we'll focus on the main triangle, triangle ADE. This green triangle AED, the sum of the angles is equal to 180 degrees, as it is true in any triangle. So which angles we have at the green triangle, triangle AED? X over 2 plus y over 2 plus 135 degrees must be equal to 180 degrees. repeat again. In the green triangle, triangle AED, the sum of the angles equals to 180 degrees. That is to say, x over 2 plus y over 2, x over 2 plus y over 2 plus 135 degrees. In total, they must be equal to 180 degrees. Again, 135 degrees plus x over 2 plus y over 2. In total, they must be equal to 180 degrees. We subtract 135 degrees from this equation, and we get that 180 degrees minus 135 degrees is 45 degrees, and it is equals to x over 2 plus y over 2. We will multiply this equation by 2, and we get that 45 times 2 is 90 degrees, x over 2 times 2 is x, and y over 2 times 2 is y. So it is x plus y equals to 90 degrees. We subtract x from this equation, and we get that y equals to 90 degrees minus x. Okay, y equals to 90 degrees minus x. In the next step, we'll focus on the pink triangle, triangle DOB. The pink triangle, triangle DOB. According to the law of cosines, cosine x equals to r squared plus r squared minus 2 squared, that is 4, over 2 times r times r. Repeat again. In the pink triangle, triangle DOB, according to the law of cosines, we get that cosine x equals to r squared plus r squared minus 4 over 2 times r times r. Okay, this is equation number 1. So here we have cosine x equals to r squared plus r squared, it's 2r squared, minus 4 over 2 times r is 2r squared. Here we split this side of the equation to 2 parts, and we get that cosine x equals to, the first part is 2r squared over 2r squared, and the second part is minus 4 over 2r squared. So actually cosine x equals to 2r squared over 2r squared is of course 1. Here we have 4 over 2 is 2, so in the numerator we have 2, so it is minus 2 over r squared. So actually found out that according to equation number 1, cosine x equals to 1 minus 2 over r squared. Okay. In the next step, we focus on the yellow triangle ACO. In the yellow triangle ACO, cosine y equals to r squared plus r squared minus square root of 2 squared. Square root of 2 squared is 2, so it is minus 2 over 2 times r times r. Repeat again, in the yellow triangle ACO, according to the law of cosines, cosine y equals to r squared plus r squared minus 2 over 2 times r times r. Okay, so here cosine y equals to r squared plus r squared is 2r squared minus 2 over 2r squared. So according to equation number 2, 2 cosine y equals to 2r squared minus 2 over 2r squared. We'll split this side of the equation to 2 parts, and we get that cosine y equals to, the first part will be 2r squared over 2r squared. The second part will be minus 2 over 2r squared. So I found out that according to equation number 2, cosine y equals to 2r squared over 2r squared is 1, minus 2 over 2 is 1, so here in the numerator we have 1, in the denominator we have r squared. Okay, we get those two equations. In the next step, we'll define 1 over r squared as t. So, repeat again according to our definition. 1 over r squared is equal to t. So we'll substitute 1 over r squared on both equations by t. So in equation number 1 we have cosine x equals to 1 minus 2, and 1 over r squared is t. So according to equation number 1, we found out that cosine x equals to 1 minus 2t. We substitute 1 over r squared by t in equation number 2 also, and we get that cosine y equals to 1 minus 1 over r squared is t, so it is 1 minus t. Okay, according to equation number 2, cosine y equals to 1 minus t. We use the trigonometric identity that states that sinus square theta plus cosine square theta equals to 1. So here cosine x, according to equation number 1, equals to 1 minus 2t. Therefore cosine square x will be equal to 1 minus 2t squared plus cosine square y. Cosine y equals to 1 minus t, therefore cosine square y equals to 1 minus t squared, and it must be equal to 1 according to this trigonometric identity. Okay, so we found out that 1 minus 2t squared plus 1 minus t squared equals to 1. We'll open the brackets on this side of this equation, and we get that 1 minus 2t squared equals to 1 plus 2t squared, that is 4t squared, minus 2 times 2t is minus 4t, plus 1 minus t squared equals to 1 squared, that is 1, plus t squared minus t, and it is equal to 1. Okay, so here we have 4t squared plus t squared is 5t squared, and we have minus 4t. Here it's actually 1 minus t squared equals to 1 squared, that is 1, plus t squared minus 2t. Okay, minus 2t. So we have also here minus 4t minus 2t is minus 6t. And here we have 1 on both sides of the equation, so 1 will get cancelled, and we left only with 1, so it is plus 1. Here we have 0, so it is equal to 0. We will substitute minus 6t by minus 5t minus t in this equation, and we get that 5t squared and minus 6t is minus 5t minus t plus 1 equals to 0. Okay, we take out 5t as a common factor from those two expressions. So 5t is taken out as a common factor. What is left from 5t squared after we do from it 5t as a common factor? What is left is actually t, and what is left from 5t after we took from it, what is left from minus 5t after we took from it 5t as a common factor? What is left is actually minus 1. And we'll also take a common factor from minus t from minus 1, so we take out minus 1 as a common factor from minus t plus 1. What is left from minus t after we took from it minus 1 as a common factor? What is left is t, and what is left from 1 after we took from it minus 1 as a common factor? What is left? It's actually minus 1. Why? Because minus 1 times minus 1 is plus 1, exactly like here, and it is equal to 0. So we take out t minus 1 as a common factor from those two expressions, and we get that, so t minus 1 is taken out as a common factor. Inside the brackets we have what is left from 5t times t minus 1 after we took from it t minus 1 as a common factor. What is left is actually 5t, and what is left from t minus 1 after we took from it t minus 1 as a common factor. What is left is actually minus 1. It is equal to 0. So here we have two solutions that are possible for this equation. Either t minus 1 equals to 0, and the second solution is that 5t minus 1 equals to 0. Okay? So, according to the first solution, t minus 1 equals to 0, therefore t equals to 1. According to our definition, t equals to 1 over r squared, so we substitute t by 1 over r squared here in this equation, and we get that 1 over r squared equals to 1. We multiply this equation by r squared, and we get that r squared equals to 1. We take a root from this equation, and we get that r equals to the square root of 1. Here two solutions are possible. Either r equals to the positive square root of 1, that is to say r equals to 1, and the second solution that is possible for this equation is that r equals to the negative square root of 1, that is minus 1. But because of the fact that r is a length, and a length must be a positive number, the solution that r equals to minus 1 is not possible, so we'll cancel the solution, and we left only with the solution that r equals to 1. Then we have the second solution that 5t minus 1 equals to 0, that is to say 5t equals to 1. We divide this equation by 5, and we get that t equals to 1 over 5. According to our definition, t equals to 1 over r squared, so we substitute t by 1 over r squared. That is equal to 1 over 5. We will cross multiply this equation, and we'll get that r squared equals to 5. We'll take a root from this equation, and we get that r equals to either the positive square root of 5 or r equals to the negative square root of 5. Again, but because of the fact that r is a length, it must be a positive. Therefore, r equals to the negative square root of 5 is not possible. We cancel the solution. So we left only with the solution that r equals to the positive square root of 5 or r equals to 1. Two solutions. So here we have in the drawing we have chord dB that is equal to 2 units. Chord dB is not the diameter of this circle. Why? Because any diameter must pass through the center of the circle. And because of the fact that dB doesn't pass through the center of the circle, it is not the diameter of the circle. Okay, dB is not the diameter of the circle, and it is equal to 2 units. And the diameter of the circle equals, of course, to 2r, 2 times the radius. And we know that the diameter of any circle is the longest chord on the circle. Again, the diameter in any circle is the longest chord of the circle. That is to say, the diameter of 2r is longer than dB. That is not the diameter. Okay? So, here we have, so we found out that the diameter of 2r is longer than dB. Okay? 2r is longer than dB. But dB equals to 2, so we'll substitute dB by 2, and we'll get that 2r is bigger than 2, we'll divide this equation by 2 and we get that 2 over 2 is r greater than 2 over 2, that is 1. So we found out that r must be greater than 1. So the solution that r equals to 1 is not correct, because r must be greater than 1. So we cancel the solution and we left only in the second solution that r equals to the square root of 5 units. That is actually equals to, in terms of numbers, it is 2.236 units, and that is the answer to the question. Okay, I repeat again. The radius of this circle, capital R, equals to either square root of 5 units, or in terms of numbers, it is 2.236 units. In the next step, I'll summarize the lecture. Okay. In this lecture, we found out the radius of this circle. In order to find out the radius of this circle, we use two rules. The first rule is that the central angle is twice as big as the peripheral angle resting on the same chord. Here we have peripheral angle ACB rests on chord AB, and it is equal to alpha. Therefore, the central angle AOB that rests on the same chord AB must be equal to twice as the peripheral angle ACB. Therefore, the peripheral angle is alpha. Therefore, the central angle AOB must be equal to 2 alpha. Okay, repeat again. The central angle is always twice as big as the peripheral angle that rests on the same chord, like here. The central angle, the peripheral angle ACB equals to alpha, and it rests on AB. Therefore, the central angle AOB that rests on the same chord, AB, must be equal to 2 alpha. Twice as big as the peripheral angle that is equal to alpha. And we used also the law of cosines. The law of cosines is true in any triangle. So this triangle ABC could be any triangle. The length of side AB is A units. Side AC equals to B units in its length. Side BC equals to C units in its length. And this angle BAC equals to theta. Then according to the law of cosines, C square equals to A square plus B square minus 2 times A times B times cosine theta. From this equation, it is very easy to arrive to this equation, that cosine theta equals to A square plus B square minus C square over 2 times A times B. Okay. In the next step, we define the center of this circle, this point as O. Then we join points O and B together, O, and we join points O and D, O and A, and O and C. So we have 4 line segments, and they are all the radii of this circle. Why? Because they start from the center of the circle and ends at any point on the circle. And this is exactly the definition of a radius. So OB equals to OD equals to OA equals to OC. It is equal to capital R. They are equal to capital R. That is the radii, the radius of this circle. According to our definition, capital R is the radius of this circle. Then we defined this angle ADC as y over 2, and this peripheral angle ADC rests on chord AC. And according to our definition, it is equal to y over 2. And according to the rule that I showed to you, the central angle AOC that rests on the same chord, chord AC, must be equal to twice of this peripheral angle. So this peripheral angle equals to y over 2, therefore the central angle must be equal to y. Then we define the peripheral angle DAB that rests on chord DB is x over 2. Therefore the central angle DOB that rests on the same chord, chord DB, must be equal to twice as big as this peripheral angle. So this peripheral angle is x over 2, therefore the central angle must be equal to x. Okay? Then we have the straight line AB at point E. This angle equals to 45 degrees. Therefore, the missing angle must be equal to 135 degrees, according to rule number 1, that the sum of the angles on one side of a straight line is equal to 180 degrees. If we focus on the upper side of the straight line AB at point E, here the sum of the angles must be equal to 180 degrees. So which angles we have here? We have this angle that is 45 degrees plus the missing angle. In total, they must be equal to 180 degrees. Therefore, the missing angle must be equal to 135 degrees. Okay? Then we focused on the green triangle, triangle AD. In this green triangle, the sum of the angles must be equal to 180 degrees. So which angles we have here? We have x over 2, y over 2, 135 degrees. In total, it must be equal to 180 degrees. Here, 135 degrees plus x over 2 plus y over 2 must be equal to 180 degrees. We subtracted 135 degrees from this equation and found out that 180 degrees minus 135 degrees is 45 degrees. It is equal to x over 2 plus y over 2. We multiply this equation by 2 and we found out that 45 times 2 is 90 and x over 2 times 2 is x, y over 2 times 2 is y. So in this side of the equation we have x plus y equals to 90 degrees. Then we subtracted from this equation x and found out that y equals to 90 degrees minus x. Okay, y equals to 90 degrees minus x. And then we implemented the law of cosines on the big triangle, triangle DOB. According to the law of cosines, cosine x equals to r squared plus r squared minus 2 squared, that is 4, over 2 times r times r. Repeat again. The pink triangle, triangle DOB, cosine x equals to r squared plus r squared minus 4 over 2 times r times r. So cosine x equals to r squared plus r squared is 2r squared minus 4 over 2r squared. So cosine x equals to, we split this side of the equation to 2 parts. The first part is 2r squared over 2r squared, and the second part is minus 4 over 2r squared. 2r squared over 2r squared is of course 1, and here we have minus 4 over 2 is minus 2. So in the numerator we have minus 2, in the denominator we have r squared. So we found out that according to equation number 1, cosine x equals to 1 minus 2 over r squared. Then we focused on the yellow triangle, triangle AOC. We implemented the law of cosines in this yellow triangle, triangle AOC. According to the law of cosines, in this triangle AOC, cosine y equals to r squared plus r squared minus square root of 2 squared, that is 2 over 2 times r times r. Repeat again, in the yellow triangle, triangle AOC, according to the law of cosines, cosine y equals to r squared plus r squared minus 2 over 2 times r times r. So cosine y equals to r squared plus r squared is 2r squared minus 2 times r is 2r squared. Then we split this side of the equation to two parts. And we got that cosine y equals to, the first part is 2r squared over 2r squared, and the second part is minus 2 over 2r squared. So cosine y equals to 2r squared over 2r squared is 1. And minus 2 over 2 is 1, so in the numerator we have minus 1, in the denominator we have left only with r squared. Okay, we have here two equations. Then we defined r, 1 over r squared is t, that is to say 1 over r squared equals to 2 according to our definition, and found out that cosine x equals to 1 minus 2 times 1 over r squared. So, and 1 over r squared is t. So it is 1 minus 2t. Okay, cosine x equals to 1 minus 2t. And we have the second equation, cosine y equals to 1 minus 1 over r squared, and 1 over r squared is t. So in total, cosine y equals to 1 minus t. Repeat again. Cosine y equals to 1 minus t. Then we used the trigonometric identity that sine square theta plus cosine square theta equals to 1. And according to this trigonometric identity, sine square theta here we have actually sine square theta. Here we have actually cosine y. Cosine y, we have already found out that cosine y equals to 90 degrees minus x. Repeat again. Cosine y we have already found out that we have cosine y. We have already found out that y equals to 90 degrees minus x, so we can substitute y by 90 degrees minus x, and we get that cosine y y is 90 degrees minus x, and we have cosine 90 degrees minus x, it is equal to sinus x. So actually we found out that cosine y equals to sinus x, therefore we can substitute cosine y by sinus x. Okay, so here cosine y equals to sinus x, so we substitute cosine y by sinus x, and cosine y equals to 1 minus t, therefore cosine y is sinus x, and it is equal to 1 minus t. Okay, so I found out that sinus x equals to 1 minus t, therefore if sinus x equals to 1 minus t, it means that sinus square x must be equal to 1 minus t square, and plus cosine square x. If cosine x equals to 1 minus 2t, it means that cosine square x must be equal to 1 minus t square. In conclusion, we found out that 1 minus 2t square plus 1 minus t square equals to 1. And then we open the brackets on this side of the equation, and we found out that 1 minus t square equals to 1 squared, that is 1, plus 2t squared is 4t squared, minus 2 times 2t is minus 4t, plus, we open the brackets here, 1 minus 2t squared is 1 squared, that is 1, plus t squared, minus 2 times t is minus 2t equals to 0. Okay, so here we have 4t squared plus t squared is 5t squared, minus 4t minus 2t is minus 60, and finally we have 1 on both sides of the equation, so 1 will get cancelled and we left only with 1 here, so it is plus 1. That is equal to 0. So we have the equation that 5t squared minus 60 plus 1 equals to 0. We substituted minus 60 by minus 5t minus 1t, and we got that 5t squared and minus 60 is minus 5t minus 1t plus 1 equals to 0. Then we took out 5t as a common factor from those two expressions. So what is left from 5t squared after we took from it 5t as a common factor? What is left actually t? What is left from minus 5t after we took from it 5t as a common factor? What is left is actually minus 1. And we have here, we took out minus 1 as a common factor from minus t and from plus 1. What is left from minus t after we took from it minus 1 as a common factor? What is left is actually t. And what is left from 1 after we took from it minus 1 as a common factor? What is left is, it is actually minus 1. Why? Because minus 1 times minus 1 is 1. And is equal to 0. Then we took out t minus 1 as a common factor from those two expressions. So what is left from 5t times t minus 1 after we took from it t minus 1 as a common factor? What is left is actually 5t. And what is left from minus t minus 1 after we took from it t minus 1 as a common factor? What is left is actually minus 1, and it is equal to 0. So here we have t minus 1 times 5t minus 1 equals to 0. So here we have two solutions that are possible for this equation. Either t minus 1 will be equal to 0, or 5t minus 1 equals to 0. So according to the first solution, t minus 1 equals to 0, it means that t equals to 1. According to our definition, t equals to 1 over r squared. So we substitute t by 1 over r squared in this equation, and we found that t is 1 over r squared equals to 1. So 1 over r squared equals to 1. We multiply this equation by r squared, and we found out that r squared equals to 1. We took a root from this equation, and we found out that r equals to plus minus the square root of 1. So either r equals to minus 1 or to plus 1. But the solution that r equals to minus 1 is not possible because y is a length, and a length must be a positive number. So we cancel this solution, r equals to minus 1, and we left with the second solution that r equals to 1. Then we have the second solution that are possible from this equation is that 5t minus 1 equals to 0. It means that 5t equals to 1. We divided this equation by 5 and found out that t equals to 1 over 5. And according to our definition, t equals to 1 over r squared, so we substitute t by 1 over r squared and found out that 1 over r squared equals to 1 over 5. Then of course multiply this equation and found out that 5 equals to r squared. We took out a root from this equation and we found out that r equals to the square root, to plus minus the square root of 5. So either r equals to the negative square root of 5 or r equals to the positive square root of 5. R cannot be equal to the negative square root of 5 because of the fact that r is a length, and a length must be a positive number. So we cancel this solution and we left with the only solution that are possible, that r equals to the positive square root of 5. Okay? So we have here two solutions that are possible for r. Either r equals to 1 unit or r equals to the square root of 5 units. But if we look again on the drawing, we have here a chord dB equals to 2 units, and the chord dB is not the diameter of the circle. Why? Because it doesn't pass through the center of the circle, that is to say, it doesn't pass through O. Any diameter must pass through the center of the circle, that is to say, for point O. And because of the fact that dB doesn't pass through point O, it is not the diameter of the circle. Okay? And we know that the diameter of any circle is the longest chord of the circle. Therefore, the diameter 2r is, of course, the diameter. 2r is the longest chord of the circle. So 2r is greater than dB, that is not the diameter of the circle. Okay, 2r is greater than dB. 2r is greater than dB. But dB equals to 2 units. So we substitute dB by 2, and we found out that 2r is greater than 2. We divided this equation by 2. So, and we found out that r is greater than 1. So the solution that r equals to 1 is not possible because r must be greater than 1. So we cancelled this solution, and we left with the second solution, that r equals to the square root of 5 units, or in terms of numbers, this equals to 2.236 units. I'll repeat again. The radius of this circle, capital R, equals either to the square root of 5 units, or in terms of numbers, it is equals to 2.236 units. Okay, thank you very much.